Welcome to Module 4 of the Fish and People Education Resource. In previous modules, we learned about how marine organisms reproduce and how their tiny planktonic larvae disperse around the oceans. We also learned how the biology and ecology of marine animals can influence how many individuals there are in a population, how fast they grow, and therefore how they are affected by fishing. Before technological fishing, an abundance of adult fish ensured there was always a rich supply of larvae. This is no longer guaranteed. In this module, we will look at the biology of larvae themselves and how it varies from species to species. We will see how larval biology affects how far they can travel across the ocean and what this means for populations of marine animals under fishing pressure, trying to replace themselves. In Module 2, we saw how many species reproduce using larvae that drift in the plankton. We also saw how small most of these larvae are, much smaller than a drop of water. Finally, we learnt that this larval phase of the life cycle is temporary as they metamorphose to become juveniles and then adults. Just as the many species that live on a reef have different habits and behaviours, so it is with larvae. Larvae are released into the ocean currents and disperse away from the parent home. Drifting for days on currents, these invisible, microscopic larvae are the way most species move between distant islands. Trochus larvae have a small supply of stored energy. This fish larva's energy supply comes from the egg yolk it was born with, but it too will only last for 4 or 5 days in the plankton. So after only 3 days, the trochus is running out of energy. Without a reef to settle on, it will die. For this reason, some species can only make short hops between nearby islands, a journey on the ocean currents of just a few days. But some larvae are not only born with more energy in the form of egg yolk, but they also start to feed while they are living in the plankton. Being able to feed while travelling on the ocean currents recharges the batteries of these planktonic voyages. This is why some larvae can travel great distances between far-flung islands in the oceans. Some larvae just drift passively on the ocean currents, while others graduate to become active swimmers as well. But provided they can find a food source while they are in the plankton, some species can travel hundreds, even thousands of kilometres during the planktonic phase of their life cycle. Fish larvae can float in the plankton for up to 60 days. Crayfish larvae, on the other hand, can survive floating at sea for as long as 500 days. So the planktonic larval phase of the life cycle acts like a natural insurance policy. This allows marine species to recover from natural disasters like volcanoes or ice ages.
When you look at managing trochus, it can be easy. You can close off a reef, okay? The trochus spawn there, they develop into a larvae, and then they very quickly settle. And that's why on the reef, within a very short time, you have trochus coming back very, very quickly. Crayfish or fish are quite different. First of all, those organisms are not like trochus, and they move across long distances. And that is the same for the larvae. That means that if you want to protect crayfish, you would require an area slightly much larger than you would need to protect the trochus.
Here are some key messages. The larvae of different species naturally differ in the distance they can travel on ocean currents. Larvae that are able to feed can extend their planktonic life phase and travel further on the currents. And intriguingly, some fish larvae seem to be able to smell or hear nearby reefs and actively swim towards them. Now let's contrast the role larvae play on healthy and overfished reefs. On a healthy reef, adult fish are widely dispersed around the system. On predictable biological cues, they gather together to spawn eggs and sperm which become planktonic larvae. The unique biology of each species determines how many larvae are produced, the length of time in the plankton, and how far they can travel before needing to settle. After spawning, the adults again disperse away from the spawning site. Some may even move to different reefs. While this has been happening, larvae are also arriving from other areas, brought in by ocean current. If for some reason a reef has had a bad year, larvae released from other locations still arrive in the plankton to produce more fish. In different years, these larvae may arrive from different sources, at the whims of currents and weather systems. These are the mechanics of the natural reef system, a beautiful, self-replenishing system that can support people and communities, provided species are allowed to spawn and complete their life cycle. Now contrast the situation where reefs are overfished. You will recall in an earlier module, we saw how large fish produce many times more eggs than small or medium-sized fish. On an overfished reef, not only are there fewer fish spawning, but they also tend to be small, immature fish. This means larvae production is greatly reduced. The overfishing problem may be partly hidden from the local fishermen by the fact that larvae from outside the local reef system may continue to supply new adults. Hoping that your reefs will always be replenished from outside your province is a dangerous strategy for 3 reasons. 1. The arrival of larvae from outside the system varies from year to year because of winds and currents. It cannot be relied upon. 2. Many of the world's fisheries are now fully exploited or overfished, so the supply of outside larvae may also be declining. And 3. The distance between your reef and the next source of larvae may be too great for some species to cross. You will recall earlier in this module that lobsters can disperse on the currents for 500 days, and some fish for up to 60 days. However, some species have a much shorter larval lifespan and cannot swim across great stretches of ocean. This is the case for the green snail, giant clams, and dugong. There are so few of these animals left that even if everyone stopped harvesting them tomorrow, it will still take a long time for populations to build up again to their original numbers. Scientists have a name for this concept: connectivity. It refers to how populations of species are connected to each other across space and through time. To understand how reefs actually work, you need to combine an understanding of connectivity with the concepts we met in earlier modules, like age at maturity, fecundity, the life cycle, reproductive behaviour and biology, and larval dispersal. Together, all these processes regulate the connectivity of populations of fish and other sea creatures. Think of these concepts as a toolkit that allow us to understand how vulnerable different species are to fishing, and how long it will take populations of different species to recover from overfishing.
Okay, for green snail, it has a short period of larval life. So if the green snails live in Tetepare, they will just reproduce and they will settle in Tetepare or in the certain location in Tetepare. the larval will not have the chance to travel to other areas in Solomon Islands because of this short larval life.
So in summary, in this module, we learned that the larvae of different species naturally differ in the distance they can travel on ocean currents. We saw how species with larvae that can travel a long way have a better chance of recovering from overfishing. We also saw that this is only possible if there are places where overfishing has not occurred. Species with short-lived larvae will take longer to recover their populations in overfished areas. In the next and final module, we will learn how human populations have impacted populations of marine animals through time, and how we can use this knowledge for management of marine resources now and in the future.
Solomon Island is your country, and it is my country, and we have a responsibility to keep this place. We have inherited it from our ancestors, and we're just passing through. We have the responsibility to pass it on to the next generation.